Okay, so I want to claim that these are somewhat tricky problems, but there's many ways to factor the problem. All right, and certainly if you're looking at this, you might be confused completely by what to do with that denominator. And I understand that sometimes. I get stuck sometimes too and say, what do you want me to do? Well, the key is that you're making an assumption that this is going to factor into two irreducible quadratics. That's your assumption, because there's no real roots to that thing there. All right. So what I do, and what I'm saying is that assumptions can be good, but they can also be dangerous. But it can't hurt to assume that this is going to work as advertised. And what I mean by that, I'm going to get this to factor into two irreducible quadratic factors. My assumption. Now, again, someone says, what does that mean? That means I'm going to get x squared. Whoops, sorry about that. Then I'm going to get x squared. I don't know. X squared, I don't know. But I think you got a pretty good idea just by trial and error. There's got to be a 2 and a 2. All right? It's these middle things that kill me. All right? So I want to point out what I do, which may seem really bizarre to you. I write it down, but I don't know what goes in the middle. So I'm going to point out what I did over here. I said I made an assumption. I'm assuming that that fourth degree denominator is factorable over the integers. And I wrote down what I said before. What I say, I do not know what the middles were. I didn't know. I don't know. All right? So what would I do here? It's tough. It's the first part of the problem. It does make it much more difficult. You know, probably multiplying it out might help you a little bit. So I'll write that down for you. What are you going to get? X4 plus beta x cubed plus 2x squared. Don't despair yet. What I'm going to get next, I'm going to get plus alpha x cubed plus alpha beta x squared plus 2 alpha x. Don't despair yet. Plus 2x squared plus 2 beta x plus 4. I want to point out, I knew I was going to get this. I knew I was going to get this. It's the middle part. And I want to point out what the middle part has to be. Let me get this in blue. This entire middle part here must be equal to 3x squared. All right? So I'm kind of looking at it. And all I now know is these coefficients on the x squared term. And I'll write this down for you. I know that 2 plus 2 is 4 plus 2 beta must equal 3. Right? So I'm thinking to myself is, can I get that? All right? So let's take a look at that. Oh, I'm sorry. I made a mistake. It's not a 2. My error. I gotta correct myself. That was not a 2. It was an alpha. That's my poor penmanship, by the way. All right? So alpha beta must be minus 1. All right? Now what I'm going to do, I've looked at this. This is done. And what else do I know? I'll write it down for you. I know that there's no cubic terms. So I know beta plus alpha must equal 0. That's that business over here. All right? Now what does that tell me? It tells me beta is minus alpha. All right? By the way, I think I'm home now. All right? I'll tell you why. I'm kind of looking at it. And I got a relationship over here, and I'll point out what the relationship is. I have, alpha equals, or beta equals, let me write this down. So alpha, and then what do you get? Minus beta. I'm sorry, that's another mistake I just made. Minus alpha, I'll write this over here, because beta is minus alpha, equals minus 1. So what does it say? It says alpha squared is equal to 1. I got that. All right, I got that. So then the problem comes is, alpha could be plus or minus 1. All right? Now what's nice about this is this. I got relationships all over the place to play around with it. So, if alpha is 1, then beta would be minus 1. And if alpha was minus 1, beta would be 1. So I think I got it. And what am I saying about this over here? Look at the symmetry. So what do I get over here? I mean, this could be, whether I use, the alpha to be 1 or minus 1, really doesn't matter. But I got the thing factored now. What's going to be x squared? Let's see, I'm going to say minus x plus 2. And then I'm going to say x squared. Let's see, beta I will call 1 then, right? Plus x plus 2. By the way, I just want to make sure you know what I just selected. I selected this one here. And, certainly I got one last thing to check over here. And by the way, that should also be clear as day that should sum to 0. And it does. If alpha's minus 1 and beta's 1, that would just sum up to 0. So I got it factored. And yeah, this was probably the toughest thing to do in the problem. I'm going to start to erase this though, because this is the preliminaries, this is the factoring part. And you're right, this is a stumbling block for a lot of people. It's a stumbling block, but I got it factored. So what I want to do is go back to the original problem, and I got it factored, all right? Let me erase this over here, and let me write this down then. So I'm going to put down, let's write this down, minus x plus x, all right? And then what do? You got to put your the quadratic factors over here, ax plus b, and cx plus d. I don't know if I want to go through all the detail because that factoring, it took time. Let me erase this business here, though. I'm done with that. Right? What do? Multiply both sides by the LCD. I'm not sure I'm going to do the whole thing, but I'll start you with it. Because again, I think the real challenge here was that denominator. 4x cubed plus 18x plus 8 equals ax plus b times x squared plus x plus 2, whoa, plus cx plus d times x squared minus x plus 2. Now someone says, what would you do with that? There's really no good values to make everything disappear, but I can make some things disappear. For example, I just want to point out, if I chose x to be 0, you'll get some disappearance over here. What do you get on the left side? 8. What do you get on the right side? Well, let's take a look at it. The a would disappear, so you left off with b times 2, 2b. Plus, what now disappears? The c disappears. And what are you left off with? Well, if x is 0, you're left off with 2d. And this is another nice relationship for me. And the relationship is going to be b plus d equals 4. And I'm going to say that's a really good relationship to have, right? So what I'm going to do is over here, I'll just highlight that. Now, by the way, that's a really nice one. But I got to be honest with you, there's 4 unknowns. And so you really need to get 4 equations with 4 unknowns. But that b plus d equals 4 is a nice relationship. It's a simple one. So what are you going to do? You're going to set x to be a simple value like 1. So I'm not going to do it, but I want to claim if you do it, what you're going to get is an equation in A, B, C, and D. You'll get an equation in that, an equation in this. All right, then what would you do? You pick another number. Like maybe x equals minus 1. This is going to produce another equation in A, B, C, and D. You've got another equation. And I got 3 equations already. And you can pick another value. What's a good value to pick? I don't know. A value that you like. Now, certainly I wouldn't pick 0 again. You've already done it. I wouldn't pick 1 again. You've already done it. And I wouldn't pick minus 1 again. I'd probably pick 2. And what do you get over there? You get an equation in A, B, C, and D. And then what you have? You'd have 4 equations, 4 unknowns, and you could use the system of equations to solve it, and you should get the A, B, C, and D. All right? So I did the work. It was tough. I'm not saying it wasn't, but I did the work. And what I found was, I found the A was 7. I found the B was 0. I found the C was 4. And I found the D was -3. I'll leave this as an exercise. I actually found the most troubling thing about this problem, by the way, was the denominator, all right? But again, assumptions can be made that this is going to work as advertised. What's the problem with assumptions? Assumptions may not be true, but this assumption worked out beautifully. But again, there's other ways to factor these things. Do not think for a moment, I am telling you this is the only way to factor that problem. It is not. There's other ways to do that, all right? So keep in mind there's other ways to do it. And that's up to you if you want to do it other ways, all right? Thank you.